Okay, so what I'm showing you now is our traditional announcement slide. Let's go a couple of important announcements before we get into the new material for today. Now, this is going to be right away, but our first exam is going to be Friday of this week. Now, it's a 50-minute exam, and what I mean by that is I design it so that I feel like the slowest student in the class would be able to finish in 50 minutes. And I routinely have students who are really able to speed through the material, finish a 50-minute exam in 20 or 25 minutes. And so, here I've got this test for you that I think is going to be 20, 25 minutes, maybe up to 50. But my plan is to give you from 11 a.m. till 2 p.m. So that's a 3-hour period. And the reason why I'm giving you 3 hours to do a test that I expect a lot of students will finish in 25 minutes is just so that technology isn't an issue. I'm going to be sending it by email, and then you're going to be uploading it to Blackboard. Maybe you have a printer accessible, maybe you don't. If you don't have a printer accessible, then what that means is you're just going to write the solution on a scratch piece of paper. Hopefully it's like a fresh white piece of paper, not without a bunch of extra junk on it. But then you'll take a picture and upload the PDF in the same way that you have for your homework assignments using Cam Scanner. So I'm giving you loads of extra time just so that the scanning and the technology isn't the limiting factor. I want you to have as much time as you need to focus on the actual engineering economy and not stress out about a race to the clock to get it uploaded before the window closes. So 3 hours to do what I think is maybe 25 minutes. Hopefully will be enough. There's one student who's going to be taking the exam outside of that window, but everyone else has at least 2 hours of non-class time between 11 and 2. So if you have a concern about that, you can get in touch with me separately after class. I heard the clunk sound here. Some browsers are not transmitting audio properly. So my suggestion, if you're not hearing the audio, no audio, try calling in. Some suggestions here. Make sure you enable the microphone. Firefox, you may need to change browsers. The way that different browsers try and protect your webcam or audio, like how you enable the permissions may vary from browser to browser. Okay, so homework 10, just, if we look at kind of the big things on the schedule between now and the next couple of weeks. So the exam is on Friday, and we'll talk more about that in class on Wednesday. But then a week from Wednesday, so April 8th is where you'll see homework 10 needing to be submitted. And then the project is due on the 17th of April. So that's the final project having to do with the cash flow diagram for your life. Okay, we're going to be talking about economic service life analysis. Here's the rest of our semester in a nutshell. We have just come off of spring break. Pretty lame spring break, I think, for everybody. But here is the remaining topics that we're going to cover. You've probably already received the announcement that we actually won't be getting back in person on the 13th of April like the university had initially hoped that it might. We're going to be all electronic for the rest of the semester. So I've moved around a couple of due dates. A few things are still where they always were, but this is what we're going to be doing for the rest of the semester. So you can see that homework 9, you submitted that today. Homework 10 on the 8th. We got our exam here on Friday, the project due on the 17th. So I'll be uploading this second revision PDF file to Blackboard. And so you can print it off as a reference, and if you have any questions, please send me an email or let me know. I will be having my office hours, and you can contact me by Skype or email or Zoom. Lots of different ways to get in touch. All right, new material. Let's talk about economic service life analysis. By the way, this is just so awkward talking to myself in an empty room. I hope you appreciate that. I'm trying to keep things going here, trying to chat, make it natural, but it's definitely not. All right. So what we're talking about with economic service life analysis is how long you should keep things, and economically speaking, when you should replace them. And the reason that we have to do this is there are a lot of fallacies out there on how long you should own equipment and when you should replace it. And you've maybe heard people talk about before when they have a car that needs to be fixed. Let's say you've got an old car and the transmission went out, and the repair shop tells you the new transmission is going to be it's going to cost $1,800. Well, what if the car itself only has a Blue Book value of $1,500? And so they say it's going to be $1,800 to repair it, but it's only worth $1,500. And in your mind, you start to wonder, wait, does that mean I shouldn't repair it? If the cost of the repair is more than the value of the item, does that mean I should buy a new car instead? And so the fallacy sometimes people follow is that if the repair cost is more than the value of the item, you shouldn't do the repair. But actually, that's not true, because the decision is buy a new car for $20,000 or spend $1,800 on replacing the transmission. And either way, that's what you're going to get is transportation. Now, the question is the new car going to last so much longer that it's worth to buy new versus repair? That's the question that we're going to be answering with economic service life analysis. So back to the question of when do you replace an item? So the legitimate reasons to replace an item is when its reliability has reduced so that it's breaking down so often that now it's increasing your operating costs, because if you're having to repair it every month and the cost of that monthly repair is larger than the cost of a new car payment would be, then that's maybe time to start thinking about replacing the old equipment for something new. Or if the consequences of the reduced performance are such that you're losing sales or your reliability, like let's say you're going into work late and now you're at risk of being fired because your unreliable vehicle is meaning you can't meet the deadlines that you were supposed to meet. So those are all issues that are related to reduced performance, and that potentially could be a reason to replace equipment. There are others though. What if the thing that you were using can no longer do what needs to be done because the requirements of the job have been changed? So the picture here is showing an iron smelting operation, and over time it may be the case that an old steel mill is no longer able to produce a new grade of steel that's required by the market. If the situation has evolved and you just cannot meet the new specifications, like the existing equipment can do what it was originally designed to do, but it can't do this new thing, then that may argue in favor of why you'd need new equipment. So for example, in the airline industry, old planes from the 1950s maybe are still able to fly, but they may not have the same range or the same speed expectations that people have, or the comfort, or the noise, or the pollution control. So those are all factors that would go into the altered requirements. Finally, there's the issue of obsolescence. Now, it could be that you have an old computer. What's pictured here is the computer that I learned how to program on. It's an Apple IIe. It was Apple's first foray into the educational market, and boy, they must have sold millions of those things because they were in every single classroom that I ever remember seeing. Didn't have a hard drive, it just used these floppy disk drives in the side. But even if that computer still will turn on, it's just the fact that it doesn't have a graphic user interface, it doesn't have a mouse, it has a really slow processor, just lots of different things about it are making it obsolescent when compared to other more powerful equipment, where maybe it still could be used to do some new task, but it would just be so slow that it would put you at a competitive disadvantage. So these are all potential reasons to replace an item. What we're going to learn now is a methodology for how you know how long to own new equipment. And the decision criteria, or kind of the rule that you apply, is you're going to want to minimize cost. You're going to be comparing equipment, and you're going to be assuming that it can do the required job. But the question is, how many years of operation will minimize the cost of ownership? So let me explain the two curves that are on your screen. And Unfortunately, I think that I'm not able to gesture on the screen with the mouse. I don't think you can see the mouse as it moves around, so I'll have to describe in detail what I'm pointing at here. The first curve that I want to show you, the AW of AOC. So what that means is that's the annual worth of the annual operating cost. And so consider a car. And if you only own that car for 1 year, so now we're looking at far to the left on the horizontal axis, so just 1 year of ownership, the annual operating costs are going to be relatively low because in 1 year of ownership, it's unlikely to break down. And so your annual operating costs are low. But what if you bought the car new, you only kept it for 1 year, and then you sold it? So you're going to be losing, because of depreciation. There's that old saying that as soon as you've driven a car off the lot, it loses 10% of its value or something like that. Your capital recovery cost, which is the other curve, is relatively high for a low number of years, meaning that you're taking a big hit for that 1 year of ownership, with the difference between the first cost and the salvage value or the market value when you sell it back. Remember what capital recovery is. Capital recovery is the difference between the initial cost and the end of life future value sales of that thing. So capital recovery is a way to annualize the equipment ownership expense. So it's the difference between the first cost and the salvage value, and then you're turning it into an annual worth. So if you look at why that curve is going down over time, you'll notice the capital recovery curve is getting lower and lower if you own it for a longer number of years. What that means is, just as an example, a real world example, the car that I drive, I've owned it for 11 years. And I bought it for like $8,000 when I bought it. It was used. And so my annual cost of ownership is really low because I'm spreading out that purchase price over a long number of years. And so what I do start to see happening, though, is that my annual operating costs are going up. Not by a lot, that's why I still own it, but I am having to repair it more than I used to in the past. And so the blue curve is the combination of the two. The blue curve is the combination of the capital recovery costs and the annual operating costs. And what we want to do is we want to choose the number of years that minimizes the total annual worth of costs. And so, does your car cost you $1,000 a year to own? If you owned it for more years, what would be the annual cost? Would it be higher or lower? In the procedure that we're going to be going through today, you want to look for what is the lowest annual worth of cost, and then that is the definition. This word economic service life. Economic service life, by definition, means the number of years that gives you the lowest annual worth of cost. And so it's how long you should own the equipment. And it's all based on speculation, because here you are now trying to predict what your repair costs in the future are going to be. And so, there's a little bit of an art and a science to that, to estimating, how much is your car going to break down into the future. But it is a method that we can kind of make some pretty good decisions if we have careful estimates along the way. All right, so on this concept, I'm going to pause for a moment and see, are there any questions related to this curve? Anybody want to ask a question about this curve that illustrates, on the one hand, you have capital recovery costs going down, but on the other hand, the longer you own the equipment, the higher your operating costs will be just due to repairs. Okay, looks like nobody has any questions about that. Let's continue onward with some vocabulary discussion here. When we go into replacement studies, we will perform economic service life analysis for more than one equipment. Today we're just going to do it for a single piece of equipment. But when you have, let's see, I'm not sure why that tone was. Maybe someone just joined or something. All right. When we do comparisons between two different pieces of equipment, the Defender is what you own already, and the Challenger is what you're going to think about buying. And so the question will be when you do a replacement study is if you should keep your existing equipment or replace it with something new. The market value is the current value of the item that you already own if you were going to sell it before you salvaged it. So, the car I was telling you about just a minute ago, I could probably get, $2,000 for it now. It's old. So it's, if I don't sell it, it's as though it's costing me $2,000 because I'm losing the opportunity cost of selling it. So the Challenger has a cost that I can find out from the person who's trying to sell it to me, but the market value of the Defender is what I would consider as the first cost of the equipment that I already own. We've already talked about what economic service life is. That's how long you should own the item, and you know that number of years because it's the one that minimizes your annual worth of costs. The Defender first cost, as I just was mentioning, is the current market value of that equipment that you currently own. The Challenger first cost is the purchase price. And then there's this phrase sunk cost that comes into decision making. And the idea there is sometimes you'll notice if you've ever went and looked at a used car, sometimes people will tell you, well, I just put in new brakes and I changed all the fluids. Last year I put a new windshield on. So they're always anxious to tell you about the expenditures that they've made in the past. But from your perspective, that's not relevant because you take it as a given that a car should have a windshield, it should have tires, it should have brakes. Those are all minimums. And so all of the previous expenditures you've made owning and maintaining equipment are irrelevant. The only thing that comes into play in a replacement study analysis is the market value of the current equipment. And it may be that the market value of your equipment is higher because you've maintained it well in the past, but those maintenance and upkeep costs are not directly relevant. They're indirectly relevant. So you'll see what I mean when we get into the analysis in a bit. Okay, so this is the in-class exercise that we're going to work through today. I emailed you the PDF of this. If you've printed that out, bravo, that's good. Having it there, the paper copy you can add to your binder. Hopefully everyone's been keeping these in-class exercises through the semester. I'm not able to provide the printed copies now like I have in the past, but if you don't have it printed out, that's okay too, because hopefully you've got the Excel template file. What we're going to do is for this equipment, we're going to figure out how long we should keep it. This is something that would be purchased for $20,000, and if I just own it for 1 year, I can sell it to someone else for $10,000. So that means, I bought it today for $20,000, used it for a year, sold it for $10,000. So that's that MV column, if sold this year. If I sell it back after the second year, then I'll only get $8,000 for it. After the third, it's $6,000. So you can see that there's a declining market value the longer I own it. And after 5 years, it has no market value. Nobody's interested in owning it after the 5th year of its operation. You'll know that looking at the third column there, operating costs for a certain year, that the operating costs are going up. And that's just kind of a typical pattern here, that the longer you own the equipment, the more maintenance and repair costs there are going to be. And that's just for the certain year. So that's not cumulative. That third column is saying, in year 1, I have to pay $5,000 to operate the equipment. In year 2, I pay $6,500, but if I owned it for 2 years total, what that means is I spent $5,000 in the first year and $6,500 in the second year. If I own it for 3 years, then I'm exposed to all of those operating costs, $5,000 the first year, $6,500 in the second year, $8,000 in the third year. All of them are going to have to be accounted for in this analysis that we do. So if we're paying 10% for our interest rate, that's the discount rate that we're using to account for the time value of money. Remember that these amounts in the future aren't as valuable as amounts in the present. And so we have to account for the time value of money, and then what is the economic service life of the equipment. What that means is, should we buy it and own it for just 1 year and then sell it back? Or should we buy it and keep it and operate it for 2 years and then sell the equipment? In other words, how many years should we keep this in order to minimize our costs? That is the question. Now, this is the template file. This is a screenshot of the template file that I emailed you. So open up that Excel file, and you may need to switch back and forth between this Blackboard Collaborate and your Excel file. Hopefully you can still hear the audio even when you're in Excel. Yeah, hopefully you should still be able to get the audio, but you may not be able to immediately see what I'm doing on my screen if you have your own Excel tab open. So I'm going to tell you a trick. You probably don't know keyboard shortcuts. On your keyboard, there's the Alt button and Tab, and if you push Alt Tab, then you can switch between different windows that are open. So, for example, here's the starting template file, and I can Alt Tab and then quickly go back to here's the template file. Yeah, so if you want to switch back and forth between different windows on your computer, try Alt Tab. So I'm going to be here in the economic service life analysis template file, and we're going to go through the procedure of finding out how many years should we own this equipment. So this is the same data that you saw in the setup of the problem. We have 10% interest rate. The equipment costs $20,000 to buy, and so you'll notice that's a minus sign because that's the purchase price of the equipment. It means it's an outflow. These amounts, though, market value doesn't have the minus sign because that's money you're going to get if you sell the equipment. So that's an inflow to you. All of our operating costs are minuses because they're outflows. So feel free to interject with a question. You can unmute your microphone if you want to say something, or try typing a question into the chat box if anything pops up. But of course, I'm still recording this, so if you miss a certain thing, you'll be able to go back into the recording later and see it. All right, so the procedure is summarized in this list of instructions. So we're given the year, so the first year of operation. If we sell it at the end of that year, we get $10,000. It costs us $5,000 to operate it during that year. So column D, what we have to do is find the present worth of the cumulative operating costs to date. So that says here in the hints, use the NPV function of the range so far. So what I mean by that is in the first year, we've only been exposed to 1 year of operating costs. So I'm going to do equals NPV. The rate is the reference here to the interest rate. And then the value will be just this first year of operating costs. Close parentheses. All right. So what that means is it's taking the 5,000 back to time 0 from year 1. And it's finding out what would be the present value of the operating costs for that first year of operation. Now, we can't just drag the formula down, though. We have to type it in manually for each row that we're in. And the reason why is it's of the range so far. So in the second year, we're going to do NPV, and still using 10%, but now we've had 2 years of operating costs. So we want to know, for taking both of those years of operating costs back to the present, how much is it? So take the 5,000 in year 1 and the 6,500 in year 2, take it to year 0 is what we're telling with this NPV function. So 9,917. So do that same thing. I'm going to pause for a moment. It'll just be dead air. And go through and find the cumulative operating costs to date for each of those different years, following the same approach that I did where we started just with the first year. Then on the second row, we used both of the years in the NPV function. So the third row, year 3, will include years 1, 2, and 3, and so on. So let me pause for a moment, let you to work ahead there. Toyota. It's a Mazda. Okay. So let's do year 3. All right, so we've got all the PV, the cumulative operating costs to date. Now what we're going to do is we're going to take it, what we did in this column D was we found what's the present value. So we took all of these operating costs to year 0. They're in year 0 right now. We're going to spread it back out over an annual series, and so here in column E we're going to use the payment function to find out how much would it be if it was the operating costs were made to be an equal amount every year. Instead of being exposed to the fact where every year you have to pay more and more and more, what if you knew that was going to happen and you wanted to spread it out? The electric company does a similar thing where if you want, because people generally use a lot more electricity in the summer when air conditioners are running, they have this leveling program where they'll look at your electric bill from the last year and then they will charge you the same amount every month so that you don't have these huge bills during the summer. And so that's a similar kind of analogous idea to what we're doing here in column E, is we're trying to find out if instead of having a different amount for the operating costs every year, what if you just had the same amount for the operating costs? So we're going to do PMT. We're finding a payment amount at our 10% interest rate. And this time I am going to anchor it because I will be able to drag this down. And then the number of periods is the row that we're on. And then the present value amount is, I think we'll have to put the minus sign in here. Doesn't it always change on us? And we want it to stay minus. So minus of that. Okay. So that's correct. What it's saying is if you only have a single $5,000 operating costs, take it from year 1 to 0, it's that. Well, take it back to an annual amount and it's 5,000. That's just unique because it's a single year. But what if we drag this down now, what it's saying is you could, let's say if you're owning it for 5 years. If you own the equipment for 5 years, you could pay $5,000 in year 1, $6,500 in year 2, $8,000 in year 3, and so on. Or for all 5 years, each year you could pay $79.61. So it would be the same for the operating costs. And so $79.61 is more than some of the years and it's less than others, but it's just a way to make it so that it's equal every year, the operating costs. All right, so just to illustrate again what we did for that column, we're using the payment function. So it's saying use the payment function on column D. So column D was the present value. So we're going to use our 10% interest rate. NPER is how many years we're putting in. And then the present value that it's referencing is the PV, the cumulative operating costs to date. Okay. So now we have annualized the operating costs so that's an equal amount every year. Now, capital recovery. I hope that you remember how to do capital recovery. Remember, capital recovery takes into account both the first life and the salvage value. I think I had a slide that illustrated capital recovery. I'm sure I did. It's just the question of whether I can find it. Yeah, this one. All right, so what we're doing when we solve that capital recovery in Excel is we know what we had to pay to buy the item, and we know what the salvage value will be in a certain year. So we're finding out, well, what if instead of just one big cost up front and one smaller lump sum in the end, what if it was annualized? How much would it be if we had to pay a certain amount every year for the ownership? So now back to this, what we're doing in the capital recovery is we're going to use the payment function of both the first cost and the market value for this year. And so PMT, the rate, I'm going to anchor the reference up to 10% there. Okay, NPER is the number of periods, and so that's the year. The present value is our first cost. And I'm going to anchor that because it doesn't matter if I own it for 1 year, 2 years, 3 years. No matter how many years I own it, the first cost is the same. So I'll anchor the reference here to the first cost, and it's minus sign, and that's okay. And then the future value is the salvage value. So this market value is what we get in the future. So it's going to be telling me the difference between the market value and the salvage value. And I should put the minus sign in front of it because it's a cost. Capital recovery is an expense. So that tells me is if I get in and out in just a year, then the annual expense equivalent is $12,000. And so I can drag that down through all the rest of the years. And the longer I own it, the capital recovery costs are going down. So if we go back to the concepts of this, remember in the figure, the idea was that there would be, let me just paste this image in so we can refer to the image at the same time that we're looking at our data. All right, so the main concept is that the longer you own the item, the operating costs are going up. The annual worth, AW of AOC. So the annual worth of the annual operating costs keep going up the longer you own it because this junky equipment keeps breaking down more and more the longer you own it and the older it gets. But the capital recovery is getting lower and lower each year. The longer you own it, you're spreading out that initial purchase price over a greater number of years. So now the question is, if we combine the two, so now this column G is us trying to come up with the blue line. So it's adding together. That's maybe zoomed in a little too close. All right, so it's the sum of the operating costs and capital recovery costs together. So our goal is we want to minimize the expenses. So which of those is the smallest? How many years should we own this equipment if we want to minimize? And so the smallest one here, this is the smallest. So this is the economic service life. It means that this equipment should be owned for 3 years. So the best case scenario, it's best for us to own that equipment for 3 years. All right, so in a normal class meeting, I would circulate around the classroom and look to see if anybody had any questions. So let me pause the recording for a moment and see, does anybody have a question? All right, so the question of capital recovery, if you know that you're going to be, let me go back to the figure that I showed you a moment ago. All right, if you know you're going to have to buy equipment with a big lump sum up front in year 0, so you have to pay a purchase price for the equipment in year 0, and then in this illustration it's saying after 7 years you have a salvage. what would it be if you wanted to pay the same equal amount every year? So if you wanted to annualize the cost instead of just having these big lump sums, that's the capital recovery. So in the example, what we're doing is we are trying to calculate, taking into account this first purchase price and then the market value for that number of years of ownership. Let me just delete it completely so you can see from scratch what I was doing to calculate that. The capital recovery is minus PMT, 10% interest, and then into the number of periods, it's how many years. So it is, if you're on the first row, it means you're just going to only own it for 1 year. So if you own it for 1 year and then the initial purchase price was this, anchor that reference, and then the salvage value that you're selling it for at the end of the year is that, then what that amount represents, that $12,000, is effectively the annual cost of owning it for 1 year, taking into account the time value of money, remember. So then if you own it for 2 years, the capital recovery is lower because you're spreading out the purchase price over a greater number of years. So it's like you, in row 2, you at time 0 paid $20,000, and then at time 2 you get $8,000. That's the same as having to pay $7,714 at the end of year 1 and the end of year 2. It's basically, we're finding an equal annual equivalent. So for each possible row, capital recovery is just how much would you have to pay if, instead of buying it all at once and then getting a lump sum at the end when you sold it to someone else, what if you made it so that you were paying an equal amount every year? You missed what we were supposed to put in the cell. All right, hopefully you've seen that now. I've got the formula on the screen there. All right, so like I said, this is awkward as could be because you're not here and you can't raise your hand and I can't look at what you've got on your screen, and you're probably trying to toggle back and forth between my demonstration and your own screen. So I recognize that this is less than ideal, but we've all done our best today. The recording for this will be on YouTube. So, if you go to my channel on YouTube, that's just youtube.com/c/Isaac Waite, then you'll see all my videos there, and you can search for 222, and this is class 27. So the lecture video will be on YouTube, and if you have questions, you can send me an email, or you can call my office line, my office phone. If I'm not in class, I have it ring onto my laptop. If I am in class, it will go to my voicemail and you can leave me a message. So I really appreciate your maturity and your positive attitude, and we're all doing the best that we can. Let's just revisit these announcements before we go our separate ways for today. I think the announcements for today was much further down here. There we are. All right, so the big thing on your horizon is we've got an exam on Friday, and like I said earlier, I'm going to provide it to you by email, so make sure that you have access to email at 11. And there's a lot of different places where you can get internet access right now, whether it be public library, or I think that like Comcast Xfinity is providing guest access to all of their commercial access points across the country right now. Friday is our exam. A week from Wednesday will be your next homework assignment, and then I hope that you've made some progress on the project. If you've got any questions related to that, please feel free to send me an email. I'll do my best to respond. Any further questions before we finish up? All right, so material to expect on the exam. I think the best way to answer that is to revisit our course schedule and just briefly review what we've seen since the last exam. So exam 1 was on the 19th of February, and so what have we had since then? We've talked about bonds, rate of return analysis, internal rate of return, external rate of return, incremental analysis, benefit cost, incremental benefit cost, cost effectiveness analysis, and then the stuff like what we did today, economic service life and replacement studies. Although if I give you a question related to economic service life and replacement study, you're not going to be turning in a homework assignment related to that stuff until after the exam. So I'd maybe ask you a conceptual type question, but it probably wouldn't be the same depth of like intensive problem solving that you'd expect to see for some of the other topics, because you haven't had as much practice time for these two topics. But what you should really focus on being prepared for the exam is these topics, starting with bonds, which we discussed after midterm exam 1. Are there other questions before we finish up for today? All right. Well, thanks everyone for joining. I really appreciate your attention. I hope your other classes are going well. So I'll see you again on Wednesday. Take care.